This is Unit 1, Lesson 3, Tracking the Tortoise. So we're looking at solving exponential functions, and we're going to start by looking to see if the base is the same. They're both 5s, so we can compare the exponents. Let's write that down. Okay, so we're going to start by looking at x plus 1 is 2x minus 3, subtracting x and adding 3, you get 4 is x. Alright, same thing with the next one. Add 2x and add 2, so 5x is 10, x is 2. When you have two different bases, if it's possible, what we're going to do is turn them into the same base. So we can take 4 and turn it into 2 squared. I'm going to write the rest of it down. I want to distribute the 2 to the 3x, so 6x is 2x minus 8. Okay, just write a little note. 4 is 2 squared. I know that some of you watch these things without the sound, so I just want to write most everything down. Alright. Okay, so the reason they're including this one now is to make sure you distribute the 2 properly to both terms. Subtract 4x, add 4. Okay, made a note. Distributing the 3, we have 3x plus 3 is 2x plus 3. Oh, look at that. Subtract 2x, subtract 3. Yes, x can equal 0. Let's write a note. Alright. 1 over 81. I'll write a note over here. Negative exponents flip numbers. In Matthews, they give the reciprocal. I like to say flip because if it's a negative exponent in the denominator, it flips up to the numerator, and so forth. So what we have here is 1 over 3 to the 4th. So this is 3 to the negative 4. So x plus 1 is negative 4, comparing exponents. Okay, that's the ready. Next, set. We have, let's see, Jack and the Beanstalk. Time is given in the first row, and height is given in the second row. To figure out 3 to the t after 6 hours, we want to, first of all, we can say, there's my 6 hours. but we can also say 3 to the 6th, which is 729. Okay. During the same time, the same night, we've got 243 feet. We look for 243. Oh, look, there's a 243. So 3 to the 5 is 243. It's 5 hours from the table. Did we use the table in the same way? So, well, sort of, except since 243 is the feet, we had to back up, which is look for it in the height row. So we're basically sort of switching input and output. Technically what that is getting at is what's called the inverse function. So 10 hours. Write the expression in 10 hours. Now if you look at the table only goes to 7.5 hours. So we're going to have to go and actually calculate 3 to the 10th. Except it doesn't say calculate it. It just says write the expression he would type into your calculator. Little fun fact here. Okay. Next, commercial jets. So at this point, we don't have a way of going backwards properly. We're getting at what are called logarithms, which is a way of inverting exponent functions. So what we're going to have to do is, let's see, 3 to the 8th just off the table. Oops, let me do that in red. Okay, so 3 to the 9th is 19,000 some, 3 to the 10th is 59,000, and so let's try 3 to the 9.5. That calculator says. So to get to 30,000 feet, it's less than 9.5 hours. To get an exact value for 30,000 feet, we're going to need the rest of the chapter, which is logarithms, new kind of function. We can't use the table to find b of 7. Well, we can find it b of 7, 2187. We can't figure out b inverse of 11,364 because it's not on the table, but oh well. so we have, let's try b of, well, let's see, it's between b of 3 to the 8 and 3 to the 9, so let's try 3 to the 8.5. Sorry, I have a cat who's being that way. Um, okay, b to the 9, we already found. Oops, b of 9. And b inverse of 9 is 3 to the what gives you 9. So b inverse of 9 is 2. Okay. Why can we answer some heights of the beanstalk by plugging in numbers, and when sometimes we can't use the tape, we can only use the table? Okay, and notice the table, the numbers for the height get further and further apart from each other, so it gets harder and harder to back up to the top row. Is the function invertible? Justify your answer. What does invertible mean? It means you can go backwards. Yes, we can go backwards. The technical reason is each output has a different input. Okay, and this is true at least for the numbers in our table. It may not continue to be true. We don't really have that much information yet, but it does turn out to be true. How do you graph an inverse function? Um, so I know that's a lot of writing. You don't have to write it, but that's what I do. So the first point I'm going to try is 1, negative 1. I switch it to negative 1, 1. Left 1, up 1. I'm going to plot the x-intercept. I'll call it 1.3. Notice it turns into a y-intercept. up 1.3, and this point is, 2, 2, so it doesn't go anywhere. I'm going to draw that line and then try and make the curve happen basically the same. And then notice that points that are already on the line y equals x they don't go anywhere. Okay. So on the interval from -2 to 0, this g of x equals x. Notice this is the same as saying y equals x. G is the same as its inverse since it's y equals x. Switching the x and y coordinates doesn't do anything. So g inverse of x is also x on this interval. Okay, new question. A table of values for 3 minus x. Notice, yeah, the tables are on the next page. This happens very frequently. Okay, so 3 minus x is given. So notice that what you have is 4 goes to -1, -1 goes to 4, etc. Okay, so justification, I will say F inverse is the same, oops, so F inverse is also 3 minus x. I'm going to put a little note about how to do this algebraically. Because we have to do that occasionally. If it says f of x instead of y, turn it into a y. And then we switch for the y and the x, and then we solve for the new y. So for example, with 3 minus x, first step is always the easy step. Second step, I'm going to add y. And then finish solving for the new y. Oh, look, it's the same. A little note, most functions are not the same as their inverse. Okay. F of x is -2x, g of x is 2x plus 5, h of x is x squared plus 3x minus 10. So it says calculate the stated values. I also want to say write the answers simplified, i.e. with no parentheses. f is negative 2x, f of b squared is negative 2b squared. What they're trying to get you to do is think of f of thing equals negative 2 times the thing as a process where you're just dumping anything in where the x used to be. For example, f of g of x means stuff 2x plus 5 into f. And that takes a little while to think about because there's already an x in f of x. But remember, it's a template. F of thing is negative 2 thing. So we're plugging g in. And simplifying it. Okay, stuffing b squared into g. And writing it without parentheses. Oh, look, these parentheses are redundant. H of f. What was h? Oh yeah, thing squared plus 3 thing minus 10. Sorry, thing squared plus 3 thing minus 10. Negative squared is positive. Don't forget to square the 2 also. Okay, h of b squared. And then h of g. I find it, when it gets complicated, I like to write the process out, h of thing, like this. Oops, minus 10. I like to write the format out first and plug things in afterwards. We're plugging 2x plus 5 in. And I want to write a little note that says by writing 2x plus 5 squared properly. So make sure that you don't just try to distribute the exponent. Okay, start foiling. I want you to get used to just, most of the time, the beginning and end multiply to, you can add them together. So I've got a 10x and another 10x. That's 20x. It saves a lot of time if you can, most of the time, if you just learn to FOIL by combining the middle terms in your head. Okay, 4x squared is the only x squared term. 20 plus 6 is 26 x's. And then 25 and 15 minus 10 is 30. Okay, so I think we are done.